So our next example, we're going to start with a derivative instead of an antiderivative. I wanted to work it out with you. So let's look at the derivative of the natural log of the absolute value of x. And you might be wondering about why would I throw an absolute value of x in there? And one reason is that natural log of x by itself, let's write it down and then I'll erase it. The natural log of x is only valid when you plug in x strictly bigger than 0. Whereas the natural log of the absolute value of x is valid for all x not equal to 0. You can plug negative x values and the absolute value kills it. The only thing you can't plug into this guy is 0 itself. So let's recall that the absolute value of x is just x when x is greater than or equal to 0, and it's negative x when x is less than 0. And so now I'm going to work through this. So let's realize that for x greater than or equal to 0, the derivative of the natural log of the absolute value of x is the derivative of, well, if x is bigger than or equal to 0, absolute value of x is just x. So this is the derivative of ln of x, which we know from before is just 1 over x. So we've got that one. That's easy enough. What about when x is less than 0? Well, the derivative of the natural log of the absolute value of x becomes the derivative of the natural log of minus x. What am I doing? Absolute value of x is negative x when x is less than 0. The absolute value of negative 2 is negative 2, which is just 2. So now I'm going to use the chain rule, and this is just the derivative of the inside is negative 1 over the inside, which just becomes 1 over x. And so the point is the derivative of the natural log of the absolute value of x, let's write it like this. Natural log of the absolute value of x is just 1 over x for all x not equal to 0. I'm running out of room now, but what that means is the general antiderivative, you see if you can call what I'm going to write, the general antiderivative of f of x equals 1 over x is big F of x equals natural log of the absolute value of x plus c. And this is really important that we make this connection. So we have this formula here that says the antiderivative of x to the n, as long as n isn't equal to negative 1, but x to the minus 1 is 1 over x. And so now you know that the antiderivative, what the antiderivative is when n is equal to negative 1. It's just ln of absolute value of x. So we'll see this again, actually, as we go along. All right, so some examples, some other examples. If you have your function is e to the x, then your general antiderivative is, you see if you can call it, it's just itself plus c. This function g of x, its general antiderivative, big G of x, is going to be what? Arctangent of x plus c as well. So having reviewed those two formulas, I wanted to show you another kind of problem that you'll run into in the homework. So here I'm going to give you a derivative. I'm going to give you the derivative, but I'm also going to tell you one point on the graph. I'm going to tell you that, f of something is something, and I want to scroll back up to where we were looking at the graphs. When I tell you that f of 0 is negative 2, that's the information you need to figure out which one of these curves your function is. And so when I give you a point like this, you can actually find the precise function, not just a family of functions, but the precise function itself. So let me walk you through how to do this. What you do is you start by trying to write down the general antiderivative. So f of x is going to be, well, we already saw the antiderivative of e to the x is e to the x. The antiderivative of 20, 1 plus x squared to the minus 1. Let's just realize that 1 plus x squared to the minus 1 is just 1 over 1 plus x squared, and its antiderivative is arctangent. So I get e to the x plus 20 arctangent of x plus c. Pause the video if you're having any trouble with that and make sure that you get the details worked out. This is the general antiderivative. Now I want to figure out what c is. And so on the one hand, I know that if I plug 0 in, f of 0 is e to the 0 plus 20 times the arctangent of 0 plus c. All right. Well, let's keep going. That's 1 plus arctangent of 0 is 0, so that's 1 plus c. So f of 0 is 1 plus c, but I'm told f of 0 is negative 2. So that means that negative 2 is 1 plus c, so c is negative 3. And now you can write down exactly what f is. So thus, f of x is e to the x plus 20 arctangent of x minus 3. And we'll box that and we'll end this video here.